Welcome to Programming Rainbow. This is Minesweeper in C and SDL3. If you'd like to follow along, this is video number 9. You can go to github.com, Programming Rainbow, and you can clone this repository. It's called Minesweeper C SDL3. You can open it up with whatever editor you would like. And this is what the code looks like. This is video number 9. So if you're following along, if you've just pulled the code right now, you'll want to probably delete this source directory and take the code from video number 8 and copy it, rename it to SRC so you can follow along with where we are, or otherwise you'll have the code from the final video. So I'm just going to show off the project real quick. So this is Minesweeper, just going to make it a little bit bigger. This is the retro one from like Windows 3 days to all the way up to Windows XP. And we have a little smiley face that we can reset. Here is our timer here. Here's our indicator of how many mines we have versus how many mines we've indicated. So if I put an indication of a mine here, you see the number keeps going down. That doesn't mean that these are correct. Like actually, if I fail the game right now, these will be incorrect. But it just indicates how many mines you have versus how many mines you've indicated. And we do have different themes that we can do. The Italian and the non-Italian ones, and also the monochrome themes. We can do different sizes, and we can do different difficulties where it sets different amounts of mines. So that's Minesweeper if you haven't seen it before. In the last video, we were dealing with mouse events. So we were using mouse events, and we were kind of just being able to set up everything that was put into place was us being able to take those mouse events and map them to the board and deal with specific pieces of the board. And what we were doing was using the right mouse button to change the indicator if we think it's a mine or not by putting a mine there, or we could also click it again and put a question mark or click it again back. So that's what we were doing in the last video. In this video, we want to actually be able to left click on and show what is underneath, or run the algorithm to expand it out into more stuff. So luckily, we have put a lot of stuff in place already for dealing with the whole mouse. So we're just going to be adding kind of to these functions, but we're also going to be dealing with linked lists as well. I kind of want to set up the kind of push and pop from this linked list. I have a push check and a pop check is what I call it. So we've already created this, but this is going to be for our linked list right here. And what's going to happen is if I have a position I want to check, I'm going to go ahead and instance one of these with calloc, and so I'm going to have a pointer to it. I'm going to set the row and the column of it. Now if I do another one, before I even get a chance to process that one that's in the list, so I have a pointer to that, I'm holding a pointer and I'm going to call it head. If I have a new one, what I'm going to do is I'm going to just generate a new one of these. I'm going to point the next one at the old head, and then I'm going to make this new one be the new head. So every time I add to the linked list, I'm always going to add to the head. And whenever I pop anything off, I'm going to pop it off from the head. So I think this is called a single linked list or something. It's just a very simple one. Nothing complicated here. If you haven't done them before, it's kind of cool, but this is the simplest approach. Okay, so we have this structure right here. This is going to be everything we need, but I need the head of it. So I'm going to call it check head is what I'm going to call it, because it's like for checking positions. So it'll be struct node. I'm just calling it node because that's what it is in my head. It's a node is just a member of a linked list. So it's just a generic name. You could give it another name, but I decided to call the structure node, the basic thing when you're making a linked list, what you can call it. So I'm going to call this check head. So this is the head of my linked list right here. And this will be null because of the way that we are instancing this with calloc. This will be initially set to null. Because of this calloc right here, everything will be 0 initialized, or pointers will be null. I'm going to put it right under this reset. It doesn't matter where I put it because I'm going to declare the function signatures anyway, but I still like in my brain, the mouse up is going to call it, so I'm going to put it before that logically in my code. So this can fail because it's a calloc, so I'm going to do the bool. This is going to return a bool, and it's going to be board push. Push is for like pushing it onto the stack, you know. I'm imagining a stack or a queue, so I'm pushing it onto the queue, or I'm pushing it onto the stack or the linked list. So this is me adding something to the linked list. It's called check, so I'm pushing it onto check. Board. And then we just need this kind of int. We need the row and the column. So I'm going to say row int column. And the first thing we want to do is calloc this. So it's going to be node. And we're just going to call it node. We just need one of them, and it's going to be the size of struct node. And then we are going to check the pointer to make sure it's valid. If it's not valid, something has gone wrong. Node. Okay, so I'm going to use the fprintf because I want to send it to standard error, just like I've done before. I can actually just grab it up here. This is what I'm doing is right here, same thing. I actually put equals null here. This is another way to do it. You know, I could do bang node or node equals null as a comparison. So I could do it the other way too. So error in calloc of check node. I'll just call it check node. So again, the way that you could do it like this, or I could do it like this. This is more explicit, but they both do the same thing. If node equals null, you know, it's a null pointer. Or the equivalent is this. And the reason why we're doing that is because if calloc fails, it returns a null pointer. If it returns an address, then it didn't fail. So that's a way for us to make sure that we do have a valid address. So I'm just going to set the node rows and columns to the, you know, the rows and columns. Just the row that we passed in here, and the same with the column. So we're always putting any new push becomes the new head, basically, right? So if I have a, let's just say I have a node, and I want a new node, what I'm going to do is say node, and I'm going to point to the old node. This is 1. This would be 2. And if I want a new node 3, I'll say node 3, right? Or it'll literally be like, you know, this next, then member next is going to be pointing at the other one. And this member next is going to be pointing at the other one. So every time I add a new one, it always to the front. And whatever this is going to be the head. So this will be head is this, right? If that makes sense. Hopefully that makes sense to everybody. I'm sure a lot of people know exactly what I'm saying, but maybe if you're very new to this idea, it might be a little strange. If I already have something set as the head, I want this node's next to be pointing at that one. So if I had a pre-existing head, that pre-existing head isn't going to be the head anymore. So it's going to be the next of this node, and this is going to be the new head. So I'm going to say node next equals b check head. Okay. And now if this is null, that's still fine because that means I have no prior, so it's null. So this will be the new head, and the next of this head will be null. That's totally fine. But if there was already a node here as the head, now this one's next head, the address of my node has a next member, which is that holds an address 2, and it's pointing to the next node, which is the old head. So now we're going to set this one as the head. So now b check head equals node. Okay. So this is taking the old head, setting it to the next of node, And now check head is node. So if I say node next, that is pointing at the old head. So I haven't lost anything. And we just need to return true. Okay, so this is how we can add things to our linked list. I call it pop because what I really want to do is I want to take something off of the head. I want to take the head off, basically, and I want to process it. But what I'm going to do is this function is going to do two things. It's going to take the head off. I'm going to basically create a temporary struct, hold that information in the temporary struct, and I'm going to free whatever that head was, and I'm going to make the next one the new head, or I'm going to do it in the opposite order. So basically, I want to process this, but I don't want it to be the head anymore. So I'm going to kind of return a node as a position, basically. So it's like I'm popping it off. It's like I'm taking one off of the queue. It's no longer in the queue, but I'm also returning that value so it can be processed. So I'm just going to use the same node struct, even though I'm not actually treating it as the list. Initially, I had two different. So let me show it real quick. So initially, I had this, and then I had another one because I want to pop the head off and return a position. So I had one called position. I just pause, and that, so this was the link list, and this was me popping one of them off, returning this position as a struct. But I thought this is unnecessary because this node is already the same as this. I'm just going to be lazy and not make another struct. This function is going to do two things. So one is returning a struct that has the position information, but the other part of it is taking the head off and making the next one the new head. And I'm going to free it. It's going to be returning a struct. And it's going to be board, pop, and this is just calling it check. And this one, we just need the board. Okay, so remember two things. One is I want to free the head and make whatever was the next thing the new head, but also I want to take the position of what was the head and return it out of this function so it can be used in another function. So it's like popping it off the list, but returning it as well. So what I'm going to do is I'm going to create a new struct that I'm going to return because these are dealing with pointers, but I'm actually just going to return a struct here. So I'm going to create that struct now. And I'm going to call it pause because my original code, this was a position. And I'm just going to I just want it to be zeroed out. Now, I'm also going to check to see if there's a head or not. I'm going to return this no matter what because I didn't make my code smart enough to not, but it's fine. But I do want to, before I start dereferencing things, I do want to make sure that I am dealing with a real pointer that's not null. So I'm going to check that. It shouldn't be. This function should never get run, but I'm just checking it anyway. In my original code, I wasn't checking this, but there's never a position that it should never be run if it doesn't exist, but I'm just trying to be safe. If this is correct, I'm going to copy over the heads row to this row. So I have what I just created pause here, this new struct. I'm going to take the row off of the head and put it here. So check head, and it is, and also the column. Okay, so if this is not a valid pointer, it's not going to do this, obviously. And these will be set to 0. So row and column will just be 0. And I'm not going to set the next because this isn't going to be used as a linked list. This is just being returned as a position. So I'm not going to be setting the next because that's a pointer for a linked list. Okay, so inside of this as well, we also basically, I want to get rid of the head, the old head, and I want to make the next the new head. So what I'm going to do is I'm going to just temporarily make a new pointer just to hold on to the head. To hold on to the address of what was the head. So this is going to be B, check head. Okay, so I just want to hold on to this real quick because I'm going to set this to something else now. So we got the check head is going to equal B check head next. Okay, now we already know that this is a valid address right here. We know that this is not null, but check head next could be null, meaning we only have one thing in our linked list. We don't have a next, but that's still okay because if check head next is null, we are setting our head to null, meaning we've just popped this one off the list and we have nothing else. But if this is a new valid one, you know, if our linked list had 2 items or more, this next item now becomes the new head. Okay, but we've held on to the old one first because I want to delete it. But if I were to delete it, I would lose this. So I'm holding this. You know, the order of this matters. If I free this node right here, it doesn't have a next. So I can't free it first. If I set this check head to next like this, then I've lost the old head. I've lost the address to it. So this is holding temporarily the address of what the old head is. This is taking the second one in the queue, setting it to the new head. Now I still have that address of the old head. Now I'm freeing it. So that's how I'm getting rid of the head. So the head's gone now. But remember, if there was a valid head before, I have the coordinates in this non-pointer. This is just kind of a position. So this is different. This is what I'm going to return. So I'm just going to return pause. So this isn't a pointer to a struct. This is just an actual struct that has a null pointer in it for next is just null, and it has the rows and columns. That's all I really need. I want the rows and columns. So this guy adds with a row and column onto my list. It keeps adding on and on and on to the linked list. And this pops the head off, returns a struct that holds the position of whatever that old head was, and sets the next one in line to the new head. So we have this push and pop going on. But the pop returns a struct. We need this because of, let me show you why we need this again. So when I click, let me redo it again. I'm going to click right here. Okay, so when I click right here, it's going to turn over the item underneath it. And if it's not a 1, if it's a 0, which is nothing, then it's going to turn over all 4 around it. And any of these ones around it, if they are also not 0, it needs to do those as well. So what happens is when I turn this over, this is going to get pushed. This position is going to get pushed and say, hey, I need to process all the way around this. And then when it processes this one, it's still, say it starts up here on the left. This one also gets pushed. So this was pulled off. This gets pushed on. It processes this. This is going to get pushed on the linked list too. This gets pushed on. This gets pushed on. This doesn't count. This gets pushed on. And this one doesn't. This one doesn't. Then this one gets pushed on. So now my linked list is actually full of 6 positions. Okay. So this one has already been popped off. It's finished, but I have this list of 6 positions. Now it's going to go do this one, and it's going to go around it, right? So that is so it can uncover all these positions. So we really need this kind of linked list going on. Let's look at the mouse down. So we've already set up the right one, but I'm going to set up the left one in front of it because that's how it is in my notes. So this is going to be an else if. I like that. So what I'm going to do is if it's the left button, so if we have a left button and then we check if we have a right button. If it's a left button, I'm only interested in one instance is if it's a 9. So if we look at these again, 9 right here means it's uncovered. it hasn't been uncovered yet. It's covered, right? So this is the state of the looking at the front board where nothing has been shown yet. And if it's this one or this one, I can't click on them. If I put a mine here, I can't left click on that. And if I put a question mark, I can't left click on it. I can only left click on this one right here. So this is number 9. That's the only one I care about. So I can say if, and I'm looking at the frontal array. Row column. And we're checking to see if it's 9. Because that's the 9. That's the image number 9, you know? And we're using it as data too, not just the image. And if this is a 9, then we are going to say the left press is the left press is true. So just like this one down here where we were checking we were checking to make sure it was 9 to 11 for the right to be true. This one, it's only 9. If it's 9, we're going to count that as a good press. And I believe that's all for the mouse down. Yeah, that's all for the mouse down. We've set everything else up. You know, we already have this stuff in place. Everything else is set up for that one. So for the up, it's going to start to get more interesting. So I'm going to sneak it in here again because I do process the left first in my notes. So I'm checking to see if it's a left key. And we've already processed up here if we're allowed to even process left clicks in here. If it's true, it's going to continue to process. If it's not true, it's going to return right away. So this has already been set up. Let's look at these again. So this is 15, this is 14, this is 13. So right here, this 13 right here means there's a mine, okay? So we're not dealing with the game overstate or anything in this video, but if this is it, this is a mine. So if I left click on this right here and underneath it is this, I just clicked on a mine, okay? But I don't want to show a mine because I clicked the wrong thing. I actually want to show this one, the red mine, because basically the game should be over now. Although we're not dealing with the game being over, I still want to show the right one. So basically I'm looking, if it's a 13, I want to show 14. So what I'm going to do is if the back array is 13, I'm going to put a 14 on the front array. So the first thing is I can only also click on it if it is a 9. So I'm going to check first, is it a 9? Then I'm going to say, is it a 13? If it is a 13, show a 19, or show a 14. The very first thing for all of this processing, it needs to be a 9. If it's not a 9, I can't left click on it anyway, so I'm pretty much done. So it needs to be a 9. So this one is front array. Front array needs to be a 9. Okay, so if it is in fact a 9, I'm going to check if it's a 13. And then we would process more, you know, game overstate or something, but we're not doing that right now. So 13, if it is, sorry, this is the back array. We're checking the front array if it's a 9. Now we're checking the back array. If the back array is a 13, we're going to set this front array position to 14. Let's just see if that's enough. Sorry, this is I'm not checking equality, I'm setting. My LSP caught me there. Okay, so let's just compile this and see if it works. And we didn't forward declare the push and pop. So there is the push, and we're not using them just yet, but they still need to be. So the only thing that is going to flip over for us right now is if it's a mine. And I don't know where the mine is, so I'm just clicking different places. There's got to be a mine somewhere. Or it never does anything because the code's not right. That could be a thing too. Oh, it did work. That was a mine there. So not very eventful, but at least we know. Oh, there's a mine there too. So it is doing something right now. Okay. Well, we'll keep moving on because it's really hard to check anything with it's not basically turning over anything else yet. If it's not a 13, we're going to immediately pass whatever is on the back array to the front array. We already know it's a 9, so let me just show you that real quick. So we were checking if it's a 13. If it's not, we still want to process it, right? So we know that it's a 9, so this is going to be something we're showing. The 13, it means that, it's a mine, but we need to show the other mine. For every other case, we just need to show what's underneath it. So we're just going to set the front array to whatever the back array is. This is row, column. Yeah, let's check this one first, and then we'll continue on, because right after this is where we get to pushing and checking the other stuff. Okay, so I should just be able to click on any of these now, right? Now let's check to see if the indicators work. There's an indicator there and a different indicator. So I should not be able to click on this one. Yeah, nothing's happening. And over here, nothing's happening. But up here, okay. And if I turn this one off, I can click on it now. So that's what those indicators do. They just stop you from accidentally clicking. So it looks like it's working pretty good here. We're not uncovering the whole board. We haven't set up this algorithm yet, but we are at least correctly uncovering what we're allowed to see. So now we need to deal with this algorithm that does stuff for us. So if the back one is 0 image, so if it's this 0 image right here, that means we need to process all the ones around it. So this is going to get pushed onto the linked list. So we'll say if, and it doesn't matter if we check the front or the back array here because they're both going to be the same. They're both going to be 0, but we could just check the back one. So if it does equal 0, then we need to run an algorithm. So the first thing I'm going to do is a board push check. And since the push action returns a bool, it can fail. I need to wrap this in an if statement. So the push is returning true or false right here because of the calloc action here. Okay, so the push check, basically we need the row in the column and we need a pointer to the board. And if this comes back negative, we're just going to return false out of here. And this is already set up with the bool here, so we're good to go on that. So this is going to push something onto the linked list, but we're not processing the linked list yet. So there needs to be another function right here that's going to start processing the list. I'm going to put it above the push and the pull because it's going to use those right here. So this is going to be called board uncover. So it's like uncovering a piece or uncovering multiple pieces. And it's going to return a bool because of this can push stuff onto the check and pop things off of it. So that bool that returns from the push needs to be, wherever that fails, it needs to come all the way down and collapse all the function calls. Board uncover. And this is just going to take the board. It's really just dealing with the head. The check head is what we're really dealing with. And we're just going to run a while loop on it. So remember, while we've created a node and while we have this head that exists, we pop one off, but while we're doing that, we might put more on it. So I want to keep processing it as long as that there's a valid address on that check head. So I'm going to just wrap it in a while. So while this is a valid address, I'm just going to keep running it. And the very first thing I want to do is pop the first one off. So if I only have one thing on my head, I'm going to pop that off, and immediately my head is actually null now. So back through this while loop, it would fail out, or it would stop. And I'm return that node as a position. So I just want this. I know I'm still using node, but it's really in my head a position. And this is a board pop check. So we already have this function set up. And yeah, these are, it's good that I'm forward declaring these function calls because I'm using those down there. But so now I have this position to process. And if it finds any more, it can, repopulate that check again. But if it was just one, this is now null and I have a position. So when we're looking at these positions, I need to go from the -1 to the positive. We've seen this before. Probably in here, right? Yeah, like this one right here. We need to do the same thing right here. I could do it this way and keep it nested, or I could do it another way where it's continued, where it doesn't become nested. So we are going to be doing rows and columns the same. So I'm going to take this, but I'm going to do it differently. I'm just going to take it down here. Because this becomes very nested, it keeps being tabbed in and in. So what I could do instead of this is I could do this initial one up here. And this is pause.row because this position we just created right here. Yeah, that's all the same now. And this one is the same for column. But instead of doing this nested, what I'm going to do is I'm going to use continue instead. So I need to do the opposite of this. So I'm going to say if it's smaller than 0, or if it's bigger or equal to rows. Okay. So if it is, I'm going to just say continue. And then close it up. I'm not sure why my stuff isn't lined up here. What's happening? Weird. Looks fine, but it keeps coming up as the wrong indentation. Huh. So since I've done this, I've used this continue. I can back this for loop up here now. And I can do the same thing here as well. Again, I need to reverse it. So let me show you again. So this is equivalent. So this kind of thing right here, this is like exclusive. I'm trying to exclude. If I'm outside of bounds, I'm continuing. And this one is if I'm inside of bounds, I'm continuing inside of this. So this continue right here means I'm not processing this part of the for loop. I'm going to continue on to the next instance of the for loop. Whereas this one says I'm going to continue inside of this nested if. So they're different, but they're doing the exact same thing, except they're written opposite, and they don't cause more nesting. This continue just allows it to continue here. So when I do this, I need to switch the sign of this, and I also, since I have an and here, this needs to be an or. This is not written right either. I'm missing something here. Wait. What's going on up here? This is not right. This should be if C is less than columns. Yeah, that's weird. I didn't see a bug from it, but that's definitely not right. So I need to do, like I said, the opposite. So this one, this R is less than becomes R is greater or equal to 0. And then this or here, instead of an and then this one is going to be C is greater than or equal to, where it used to be less than. And this is going to be a continue. Why is this not lined up right? Huh, that's weird. Okay, so I know it looks a bit weirder. It becomes longer, but it becomes nested less. So what we're going to do is basically check a similar way that we were doing before, where we check if the front array is 9. We just move whatever's in the back array to the front array. And if the back array is 0, we push it onto the thing again. So we're going to do this exact thing right here. Where is it? What we did on the initial one, the mouse up. So right here, where we're checking if it's a 9, and then if it's a 0, we're pushing it. We're going to do that same thing. And this is fine. We'll never get any kind of doubling because we are checking to see if the front one. So let me just show this real quick. I just want to uncover. So if I clicked here and I start processing these, right? Assume that nothing is uncovered, right? And I clicked here, and my algorithm processes here. It flips the 1 over. It checks first, is this a 9 here? Okay. And then it flips the back one to the front. We got a 1. It does the same thing. Is this a 9 here? Yes, it is. Now it flips the back to the front. Is this a 9 here? Yes, it is. It flips the back to the front. Is this a 9? Yes, it is. And it's a 0. So it flips the back to the front. And because it's a 0, it pushes this onto the queue. Now it gets here. Is this a 9? It's not a 9 because we've already flipped this one. So it doesn't process this. It doesn't process ones we've already processed because it's first checking, is this a 9? And then is this a 9? Yes, it is a 9 because we haven't done anything yet. And it's going to push another one on to the queue. And it's going to push one onto the queue. And then it's going to flip these 2 over. So that's the idea. So we don't have to worry about multiple processing the same one over and over again because it's going to first check, is it a 9? So we say if, and we're going B front array. And this is going to be RC. So we are checking first if it's a 9. And then we are going to just transfer whatever's in the back to the front. If it is a 9, whatever's in the back is getting transferred to the front. There's no chance of this being a mine, okay? If we've clicked on a spot without a number, there is no mine touching us. There can only be a 9 touching us if there's a number there. If there's a 1, there's one mine that could possibly be touching us. But if it's a 0, there is no mines touching us, so we don't have to worry about dealing with a 13, 14, none of that stuff. We know that our original position is not a mine. If it's a 0, there is no mines touching it. So we're just straight up transferring what's ever in the back to the front. RC just equals B back array RC. So we've done that. Now we just need to check if it's a 0. If it's a 0, we're going to push it onto the queue again. And it doesn't matter if we check the back array or the front array. I guess we could check the front. Because it'll be 0 either way. Okay, so if it is a 0, now we're going to do the push thing, but this can fail. So we have to wrap this in an if. Push, check. And we need the board, and then we need the position, which is the R and the C. If this fails, we need to return false out of here. And this is already set up with a bool, so that's okay. Since this is set up with a bool, we need to return true out of here. Okay. So this is our algorithm, basically. It's going to look for everything around the whatever spot we just were on, what we're checking right now, whatever's this node. It's going to go around it to all the ones around it, and it's going to see if that one is a 9, if the front board's a 9, it's going to transfer the back to the front, and if it's a 0 that got transferred, it's going to push that one now to the queue. And it's just going to keep going through its thing. When this loops gets done, it goes back up to the while loop and said, hey, do you still have a head? Is there still, this linked list? Each time this gets popped off, the linked list shrinks down, we get a position. But each time this finds another 0, it puts another one onto the linked list. So since we have that function now, we can put it into our mouse up position. I'm going to close this down here. Okay, so we have this one right here where we pushed 1 on here, but now we need to call that function and check. And that function can fail, so we need to wrap that in an if statement. And that's board uncover. And we just need B for that. Okay, and we need to forward declare this uncover. Under reset. Okay, so hopefully we already have in place the right and the left buttons. Yeah, we've already been using it anyway, but we already have these in place for the right and the left button. So now hopefully we have that where it can process everything around it. So let's click 1, that's a 1. It didn't work because that should have done something. So something's weird's happening there. Let me try it again. We need an empty spot. Yeah, it's not working here. Okay, let me just see if I didn't save something. Looks like everything's saved. Okay, on board. There we go. So this is pushing, and this is checking. I'm just going to put a print statement in here to make sure that we are in the function. Okay. So we're in there. So this was not, this was valid. So we know that this is kicking off. We know we are getting into here. We should have a position. Let me just check these that I haven't messed something up here. R position row -1. R is less than, rows +2. RR. We have R is less than small or less than 0, or R is greater or equal to int rows. Continue, yes. Equals column -1. C equals 2. Yes, that's good. Oh, sorry. I didn't fix this one right here because I got caught up in looking at the other side. So that one should be like that. This one is like that. That may have just been the issue. And it looks like it's functioning now. So it just turns over everything. The mines get shown as the exploded mines, and the ones that need to uncover more do that. Let me just open it again. I'm not going to recompile it. I'll just run it. So, yeah. Looks like it's working. There's one. And here's the mine, and here's another one here. Here's a mine here, and here's a one. Looks like it's doing exactly what we want it to do now. Okay, so this is getting a lot closer. We have some stuff going on here. We need to make the face reset. We need to have the indicator here. We need to have a clock here. But this was like the kind of the big thing. We have the algorithm actually running that's uncovering the board correctly. So this looks pretty good. Let me just cover what we've done here in this one. So we have created a couple functions. I don't think there's anything new in here. Node is not new, it's from before, but we are using it in this video. We do have this new struct node check head. It's just head, it's the head of our check list, basically, our linked list. And we have these functions here for the linked list, two of them, a push check and a pop check. So the push check, all we're really doing is that node struct has a row and a column, and it also has a next. That could either be null if there is no next, or it could be pointing to the next member of the linked list. So this is calicking the new one, using calix so that everything is null or 0 set. We are setting the node row and column based on what we've passed in. We are making sure that if there was an old head, that we're setting that old head to our next, and then we're setting this one to the new head. And we're returning true because this could return false here. So that's how we're pushing things onto our list. How we're popping them off is, one, we want to return this node as an actual struct so we can use it as a position. But two, we need to remove it from the head of the list and make whatever the next one is the new head. So first we're checking to see if it's a valid address to begin with. Well, we are creating a struct up here that is initialized to 0. And we're checking to see if head is a valid address. If it is, we are setting the head row to our row of what we've just made the struct for our position here. And the same with the column. And then we basically need to get rid of this head, but we need to make whatever's the next one the new head. So we're temporarily creating this pointer to a node so that we can make the new head basically the head next, the old head next. And then we are getting rid of that node. We're freeing it. And we're returning the position up here, which is just the actual struct. So this is shrinking the linked list down. But first we've pulled out the information into a struct and we're turning it directly. So those are our two functions that push things on the list or pop them off. So we didn't have to change much in our mouse down. We just had to add this in right here. making sure it is a button left action, and making sure that it is a 9. It can only be a 9. That means nothing's indicated in it hasn't been flipped over yet. So if that is possible, we are doing the left press is true. And now in the mouse up, all this is the same except right here. This function right here is new. So this one, if it is a left press, we're making sure that it is a 9. And if the backboard indicates a 13, which is a mine, we're going to set a 14 to the front board, which is also a mine, but means like you've just lost the game. That will be processed more after that, but like it's just going to indicate that one for now. If it's not a 13, if it's anything else other than a 13, which is a number or a 0 spot, we're just going to put whatever's in the back array onto the front array. And if it is happen to be the 0, 1, we're going to push that position onto our checked list. And then after that, we are going to run board uncover, which is using that linked list to check. So that is up here, right here, uncover. So uncover, this is going to just keep running while there is a linked list in place, while check head is pointing to a valid pointer. And right away, we grab the position, we pop the head off the list, and we return that as our position. So we can check this position, but now this list has gotten shorter. And we are doing the same thing what we did, where we go -1 to +1 on this position. If we are out of bounds, we're checking if we're out of bounds here. If we're out of bounds, we're just going to continue to the next one in this for loop. And we're doing the same for the columns and checking to see that we're not out of bounds on there as well. So if we're in bounds and it is a 9 in the front, we are going to put whatever's in the back to the front. And if it is a 0, we're going to push that onto the list again. If this fails, we're going to return false. So that basically keeps going through, and that's how we uncover everything we need to uncover. That is how we're uncovering, and we've done those two right there. Mouse up, mouse down. So that's kind of gotten us a lot more interesting now that we can do this. We've also changed this right here. I think we did it in the last video. Because we had it as back, we put it back as front. Okay, so I think that's going to be everything for this one. If you have any questions, just ask, and I hope you enjoyed that or it was entertaining, and I'll see you in the next one. Bye.